What are electric lines of forces? This time we are going to visualize the electric field at a point. We will say that we have calculated electric field strength. How can we visualize it? Electric lines of force. In case of magnetism, we will say that magnetic field lines, but here it is electric lines of force. What are those? Electric lines of forces are those which will show you the direction of electric field at a point. Okay? So, let us start with this positive charge here. You know, strength of electric field changes, isn't it? We want to visualize electric field means we want to visualize the direction as well as the magnitude. Okay? So this chapter is basically visualization of electric field at a point. So it means we have to draw something, then only we can visualize. If you keep electric charge, nothing is observed. Okay? So we will attempt to draw something which will help us to understand the magnitude of electric field at a point as well as the direction. But magnitude. Okay, let us approach this manner how magnitude can be stated. You know, strength of electric field due to point charge at a point. Do you know what is the strength? Strength of electric field due to point charge will be kq by r square, isn't it? The strength of electric field is kq, k into q by r square. With distance, it varies. So, what you are going to do there? You are going to draw something which will help you to visualize. Very close to charge, strength of electric field is strong. Then it gradually reduces. You agree or not? And it is both the way. So field stronger, we are taking larger arrow. Stronger field, it is gradually reducing means the strength of electric field is gradually decreasing. That's why arrow is going to be changed. Let us approach this manner. Later on we will change this. We will replace it by some other convention. Hope you all are ready. You are doing it with me. So it is stronger at this point. At which point? It is stronger at this point in compared to this point. That's why the larger arrow here, smaller arrow there, like this. This is one thing. Now, why we are putting arrows outward? It is because electric field due to a charge, positive charge is really outward. Why? Because it is the magnitude of force experienced by a vanishingly small test charge per unit charge of it. Del Q, vanishingly small test charge, how much force it experiences, its measurement is this only, no? kq by r square. So direction of force experienced by the charge radially outward. That's why the lines of forces are directed radially outward. Is this way. Okay, I have taken these four only, but many are you can draw. How many? Is there any limitation of drawing these lines of forces? Of course. We cannot draw many lines of forces for a small amount of charge. How much lines of forces, how many these three lines are going to draw, it depends on the magnitude of charge. If magnitude of charge is large, then we plot large number of lines of forces. Okay? All these will bring under property of electric lines of forces. But right now, we'll just draw lines of forces due to positive charges. They are directed radial outward because it is direction of force experienced by positive charge. Vanishingly small positive charge. That's why lines of force is outward. And length of arrow is replaced by, those lengths we are initially considering were replaced by just one arrow. Every time we cannot put. If you want to do it, you do. Length gradually reduces. Like that. Otherwise, you have another way to show the strength of magnetic line of force. If you draw these lines of forces in all directions, isotropically, giving importance to all the directions, then something like this, one can observe that if some area is placed near the charge, this area is taken near the charge. One area is taken near the charge. And another area taken away from the charge. Then what will you observe? Near the charge, you will observe many lines of forces are passing. You agree or not? But away from the charge, less number of lines of forces passing through the area. If you keep the same area, then you get. And this also will help us to understand the strength of electric field at a point. So, if lines of forces are more dense, electric field is stronger over there. So, arrow small or large, that concept we are not doing. If you want to do, no problem. You do it. Larger arrow for stronger field and smaller arrow for reducing field. Okay? Or you have to understand by seeing the lines of forces passing through an area placed in the field. Now, can you tell me what will be the direction of electric field lines due to negative charge? How will you draw due to negative charge? Due to negative charge, it will be radially inward. Isn't it? Directed inward. Lines of forces are directed inward. Why? Because the vanishingly small test charge or a small positive charge will experience force towards the charge. Isn't it? That's why lines of forces will be directed towards the charge. If you do it for two positive charges, if we draw it for two positive charges, we initially assume that those charges are equal in magnitude. Why equal in magnitude? That one point, initially I tell you, one point is there, but field due to this and field due to this get cancelled. Agree or not? There will be a point where field due to this or field due to this get cancelled. No field will be there. That point where electric field strength 0 will be referred as neutral point. So what is the neutral point? The point, or many point may be there, at which the strength of electric field is equal to 0. Resultant. This is obviously resultant electric field strength is equal to 0. That point. So can you draw electric lines of forces? A few at least. I have taken equal charges. So it will be symmetric. How? Those lines of forces trying to come here. But this one will be repelling. It will not allow to set up the electric field of the other charge. Because they repel, no? We have to understand the strength and the direction of my electric field. So at this point, no electric field will be there. No line of force also will pass through that. So, lines of forces going to be like this. I am drawing a few only, just for understanding purpose. Why? Because they are experiencing, you should draw isotropically, yeah? But isotropically not possible here. Why not possible? Because it is changing, no? Strength is changing. The same manner, how many lines of forces are passing here? 3 to 5, 3, 8, 9. I'll draw 9 only. Why? Because I told you that number of lines of forces coming out of a charge depend on the magnitude of the charge. If charge is less, wait a minute, I was trying to go that way, but being repaired. Something like this. I am not drawing all the lines of forces. So don't say the lines of forces are stopped over there. In fact, they are going. Only at this point, when neutral point is there, no line of force will pass. Okay? So this is your neutral point. Neutral point is there where no line of force will pass. How to draw lines of forces due to one positive and one negative charge? That also can be done. Let us do it due to one positive and one negative charge. Lines of forces will come out from here. They will meet here. Agree or not? They'll meet. Not drawing all, just doing a few. Okay. So lines of forces will be terminating at the negative charge here if they are kept side by side. They start from plus q and they will be terminated at minus. Now, how to draw lines of forces if there is a charge plus 2q, another charge is plus q. How do you do it? And how do you show the neutral point? At any point, field due to this will be stronger in between these two charges due to this, isn't it? So lines of forces, more number of lines of forces, so neutral point will be close to this charge. It's a very common concept. Why? Because this one will push with larger force. Force will be lighter if you move away from this. And this one very close to it, stronger field will be this side. So neutral point will be somewhere like this, where the neutral point will be somewhere like this. This is neutral point. Okay? Why it is close to the charge plus q? You have understood? In a diagram, if you have drawn 7 lines of forces due to plus q, you will be drawing 14 due to this to depict that, electric field line. You will draw more. Okay? They will never intersect. This you have to keep in your mind. Lines of forces will never intersect. Why I will explain all these things. Okay? So I have drawn 7 due to this and 14 due to this. All these observations you do. Now tell me another thing here, because you are going to list the properties of these lines of forces. Just tell me one thing. At any point on the line of force, what is the direction of electric field at this point? It will be tangential. At this point, tangential. Everywhere it is tangential to the curve. If you keep a positive charge here, in what direction it will move? Q0, say we are placing. In what direction it will move? Towards the line of force, along the line of force. Better to say. So this is one of the very important property of line of force. And what about the neutral point? Because at those points, no lines of forces are passing. Keep this thing in your mind. So we can say that strength of electric field is 0 over 0. Strength of electric field, in this case, 0. Due to 2 negative charges, can you draw lines of forces? Try before I do it here. Due to 2 negative charges, is it possible to draw? Think. We have done plus q plus q. So minus q also can be done. This is minus q, minus q. Similar diagram. As we have drawn here, it will be similar. Isn't it? No, I am wrong. No one told me why I am wrong. Because arrows are taken wrong way. Okay? You could have told me earlier, you are sitting here. Whenever there are some intentional wrong thing drawn here, you must inform. Okay? Why? Because otherwise this will go with your copy. Yeah, it's like this. Terminating at the church. So lines of forces will be directed this way, this way, this way, going this way. Here also. Direction will be towards, isn't it? To take more, like this. Then what do you get a neutral point? Again you get neutral point at the middle of line segment joining two charges. Neutral point here. Okay? So what are the very important properties of lines of forces that we are going to list after making these observations? What are the observations that we have done? We'll remember it again. Properties of electric lines of force. Properties of electric lines of forces. Number one property, we remember this, that they always start from positive charge and meet at a negative charge. So they start, or you better you write this, they emanate out from a positive charge, emerges out. Emerges out of a positive charge and terminate at a negative charge. Number two, see, when they're coming out, suppose you have kept some positive charges inside this surface. Lines of forces are really outward. So when they are coming out of the surface, they will be perpendicular to the surface. When they meet, then also it will be perpendicular. So they always meet a surface perpendicular to it. They emerge out also in a direction perpendicular to the surface. So they meet or emerges out perpendicular to the surface. Number 2, direction of electric field at a point is tangential to the line of force. Okay? Tangential to the line of force. Two lines of forces never intersect. Two lines of forces never intersect. Why they cannot intersect? This I will explain by drawing. Yeah, this thing. Suppose they intersect. We are going to prove this by contradiction. This is one line of force. This is another line of force. Suppose they have intersected. At this point, they intersect. So this is one line of force, curve 1, curve 2, and meeting point is P. So what is going to happen over there? That at the point P, this is line of force, no? Suppose directed this way. So electric field strength will be tangential to the surface, directed this manner. At this point also, it is tangential, agree or not? Just have said it will be tangential to the surface. Tangential to the surface C2. So at the point P, electric field has two directions. Not possible. Why? The answer is there will be two directions of lines of forces otherwise. Otherwise, there will be two directions of electric field, better to say. Two directions of electric field. That is not possible. Number 5. If you do the experiment, suppose I have told you to check whether lines of forces passing through that point or not. How will you check? How to check lines of forces passing through a point or not, through a region of space or not? If you put a charge particle over there, charge you cannot see, but charge particle there, that you can take. Many charges are there. That charge you place that point. If it is movement, then you will understand that electric lines of forces are passing through that. Because this time, definition of electric line of forces we can make this manner. Just I am writing good definition of electric line of forces. Electric lines of forces are those along which electric lines of forces are those along which an unit positive charge, along which, don't say an unit positive charge, along which a positive charge moves if it is free to do so, or those along which a positive charge moves if it is free to do so. Electric line of forces are those along which a positive charge can move if it is free to do so. Keep this concept in your mind. So, now I am going to state that inside conductor, no line of force can pass. That's why electric field strength will be 0 over there, inside conductor. That we bring under property 5. They cannot pass through a conductor. They means what? Lines of forces. They cannot pass through a conductor. So, they cannot pass through a conductor. So, strength of electric field inside a conductor is equal to 0. Okay. Then number 6. For positive charges, what have you seen? For two positive charges, what have you seen? Lines of forces are moving away from each other. Why? Because they repel. Why? Because they cannot intersect. They repel. This is the main reason. So, don't you think that here it seems that lines of forces are exerting lateral pressure on each other? That's why they are getting separated from each other. This will come under property. They exert lateral pressure on each other. They exert on each other. Okay? They exert lateral pressure on each other. What is the effect of it? No, lines of forces length will be increased or decreased. It will. They exert lateral force, lateral pressure on each other. So, they will be elongated longitudinally. Length will be increased longitudinally. Number 7. They contract. Lines of forces may contract. How to say that? Because of positive and negative charge, it seems that they are shortened. Due to a plus Q charge, they are moving away. But here, it seems that due to their attraction, the length of line of force is getting decreased. Lines of forces may contract. It proves the force of attraction between two dissimilar charges. They exert lateral pressure on each other. What does it imply? It proves the force of repulsion between two static obviously, static positive charges. Okay? Clear? Understood? Number 8. Number of lines of forces due to a point charge or many charges depend on number of lines of forces due to a point charge depend on the magnitude of charge. Okay, it depends on the magnitude of charge. I'm just drawing a diagram for better understanding. I'll ask you to compare the lines of forces, compare the magnitude of these two charges. Drawing lines of forces here. And then you decide what's the ratio between these two charges. Find Q1 by Q2. They have asked you to find this. We'll have one complete session on this kind of problem. Just today you have the introductory idea. Okay? Tell how to find Q1 by Q2. How many lines of forces are coming out of Q1? How many are there? 3, 6, 7, 8, 9, 10, 11, 12. Okay? So number of lines of forces coming out 12. That will be 12. That divided by how many are there? Okay, take one more if you like. Leave it. Okay. 3 to 5 to 7. 12 is to 7. So ratio between the magnitude of two charges is 12 is to 7. Okay, this property I forgot to tell you. Number 9. Lines of forces cannot pass through a conductor. Can never. That is why I have told already. Oh, they cannot pass through conductor already stated. So no need to. These 8 properties. Okay. Now, one very important thing I give you introduction now. When you start Gauss theorem, this concept will help you. Okay? Electric field strength at a point depend on number of, from above discussion, we just draw some conclusion, an important conclusion. number of electric lines of forces gives the measurement of Fs over there. Number of electric lines of forces gives the measurement of electric field strength at that point. Just what we have observed that we are going to write. In fact, EFS at a point is directly proportional to the number of lines of forces passes through an area, obviously unit area or a small area, unit area will take no problem. Like the number of lines of forces passing through an area placed at the point held in a direction perpendicular to the direction of lines of force. Okay? And suppose you are doing this for any type of field, that is never possible. For a non-uniform field, this calculation will change. For a uniform field, it will help, isn't it? For a uniform field. Now, I haven't told you anything about uniform field. What is when you say that field at a point uniform? Field at a point uniform if lines of forces are parallel to each other. If they are not parallel, field will not be uniform. Uniform electric field in a region is represented what way? By drawing equidistant parallel lines. Uniform electric field in a region is represented by drawing equidistant parallel lines. So, if you draw parallel line this manner, okay, I am taking along this direction better. This field is uniform. Okay? This field E is uniform. But if we how do you produce uniform electric field in a region? We haven't done capacitor, but I'm just telling you in terms of this surface charge distribution. To create uniform electric field in a region, we mount these two plates parallel to each other. Okay? This plate has only positive charge. Uniform surface density of charge is there, sigma, and it is minus sigma. Here, lines of forces will be parallel to each other. It go this manner. In between, lines of forces will be uniform. E is uniform here. Then somebody has taken lines of forces like this. I'm going to draw it here. In a region of space, or they are coming out, whatever, then is non-uniform. Diagrammatic representation of non-uniform electric field we don't do normally. Our interest is with uniform electric field over there. Okay? Now, why I am doing this? Because for a new definition of strength of electric field, I have told so many things. Electric field depend on number of lines of forces. Isn't it? Directly proportional. Now I am telling you in terms of unit area. This is very important to understand Gauss law. Keep this concept in your mind. Definition of E. It is defined as the number of lines of forces passing through an unit area held in a direction perpendicular to the direction of lines of force. Okay, just let me illustrate with this diagram. I am taking lines of forces this way. This way. Okay, I am telling this uniform electric field is E. There is an area which is held perpendicular to the direction of lines of force. I am keeping it this manner. That area I am keeping this way. I did not see unit area. This uniform electric field magnitude I am telling you. This suppose E equal to 10 Newton per Coulomb. And this area is 50 meters square. Find these lines of forces are perpendicular to the surface. Find total number of lines of forces passing through the surface at right angle to it. passing through the surface of area. I have shown the area. I have stated the magnitude of electric field. Now, my question, how many lines of forces are passing? Use the definition. Through unit area, how many will pass? By definition, E. E stands for what? Number of lines of forces passing through an unit area. I told you, no? This was unit area. So this is measurement of the lines of forces passing through unit area. If you have kept 1 meter square area, how many lines of forces will pass? 10. But it is 50 meters square. So how many lines of forces will pass? Number of lines of forces passing through the surface is equal to 50 into 10. That is 500. And this will turn as electric flux. Total number of lines of forces will pass through this surface whose area 50 meters square will be 500. And this will represent electric flux to the point 500 in number. Okay? Understood? Next session I am coming with calculation of electric field due to what? Due to combination of two charges, that is known as electric dipole. And in the same context, today only I am going to discuss electric field strength in some peculiar cases. Okay? Get ready for it.